All right, guys. Worksheet 2, we got partway through yesterday, so we're going to finish that. I was actually really happy that we did 2 of the 3 variable ones, and we got 1 left to do today, because it's a tricky concept, so it's a good thing to repeat on a second day. We're going to try to do the same thing with matrix multiplication. I'm going to try to get as far as multiplying matrices today, and then we'll pick up with it again tomorrow so that you see it twice, okay? Because it is by far the most complicated of the matrix operations. All right. Repeating about the quiz, there is a quiz Thursday. It looks like worksheets 3, 4, and 5. One more time, the quiz on Thursday looks like worksheet 3, 4, and 5, but you can't use the graphing calculator. Any questions about that? All right, we're going to finish worksheet 2 today, in which case you will be ready for the quiz. Then we're going to start talking about matrices, which are not on the quiz at all this time. All right, so our SAT bell ringer question of the day here. Anybody look and think they figured out a choice? Last week we talked about U substitution. Do you remember that?
Yes.
If I replaced 5A, that whole parenthesis thing, with a U, what would this say? Okay. If momentarily I got rid of the B, could you factor that? What could you do? And I'd get U minus 1. We good so far? All right. Now, instead of U, okay, first of all, instead of U, it was 5A, yes? Okay. So right here, when we took out, well, I'm just going to write it 5A squared, 5A minus 1. But there's another issue here, okay? There was a B. So when we started with this, what do you do with the exponents when you factor? You're really dividing, yes? Think about that for a second, because some of you are looking like I'm crazy. When I do this, I really divide it out at 2, yes? So we're dividing. What do you do with exponents when you divide? Subtract. Everybody all right? So if I'm taking out a 2B, I'm subtracting it. So what? Oh, didn't mean to erase. I meant to use. Okay. If I took a 3B and subtracted out a 2B, there'd still be what left? 1B, yes? If I had 5A to the 2B and I took out a 5A to the 2B, I divided it out, there'd be 5A to the 0 or 1. Which choice is that? Okay, I want to remind you, this question is one of the questions that would be in what's called advanced math or passport to advanced math or something. Okay, this is not one everybody's going to be assumed to get right. Okay, this is a tricky question. Yes? It would not be. The issue is there's 2 variables, so you'd probably have to plug in a number for both. But yeah, absolutely, that's always a great strategy. Okay, if you decided to let A be 2 and B be 3, plug them in, see what you get up here, plug them in down here, see which one gives you the same answer. When you're picking things like that, don't pick 1 or 0, because then a lot of times you'll get, 3 of them might be the same down there if you put in a 1 or a 0. Does that make sense? Good, good, good. Okay, guys, this is the notes that we left off with. We didn't do this one yet. We said the first step to solving a 3-variable system was to choose a variable to eliminate. We could pick X, Y, or Z here. Let's talk about the pros and cons of each. Cassidy, do you have this? Were you here yesterday? Okay, you were just gone the day before break, right? I forgot, sorry. If we picked X, guys, we could multiply this one by 3 and add it to this one. We could multiply this one by -2, add it to the one above it. But we'd have to multiply both, right? If we picked Y, we could make this a 4 and that a 4. We could make this into a 4 and it would add to that one to be a 4. But what seems the easiest choice, maybe? Yeah, do you see where Z, if we pick Z, even though 6 is a bigger number to multiply by at some point, at least we don't have to multiply the first time. So that's what I'm going to go with. I'm going to choose Z, and I'm going to say the first thing I'm going to do is simply add equation 2 and equation 3. So when I do that, what will I come up with if I add these two? Now, some of you will notice you could actually divide all that by -3 and it'd be a pretty nice equation, right? But I'm just going to leave it because some of you wouldn't notice that, and it's not going to make a difference in the end. All right, we're on step 3 here. We need to use 2 different equations and eliminate the same variable. So I have to eliminate Z. I'm thinking if we use the first 2, we would need to multiply the second one by what? 6. So I'm going to add number 1 to 6 times equation number 2 by putting it in words. So I'm going to rewrite number 1. And then I'm going to do 6 times number 2 and write it underneath here. It'll be -36x minus 6y plus 6z equals 0 still. Everybody all right? So what do you get when you add those together? Yeah, nice disgusting -34x minus 2y equals -2. I wish I was 34 again, but all right, right here, these two we're going to add. We need to do something with those two now. Not nice numbers, right? I'm going to rewrite it over here, and I'm with you. I probably would have simplified somehow, but I'm not going to bother because I don't want to confuse anybody, okay? We're just going to get rid of the y's. So how could I get rid of the y's? If I was in Algebra 1 and I saw this problem, most of you wouldn't think to divide through by a 3, right? Back in Algebra 1, you would have said, I need to make this a 6 and a -6. Does that seem okay? So I'm going to multiply this one by a 2 and this one by a -3. Will that work? So I get -18x minus 6y equals -6. And the second one is a lovely -102, 112. Somebody help me out. 34 times 3, 9, 10, 102. Plus 6y equals +6. What happens after all that crazy business and all those huge numbers? Yes, the y's drop out, but this is also equal to 0. So, I don't know, is it 84? I'm not sure I did that right, but it doesn't really matter because we divide and we get 0. Oh, are they both supposed to be negative? No, this was supposed to be positive. There we go. Is that better? Is it still 80? Is it 84 or did I subtract one? Okay, thank you. Yes. Whew. All right, we got 0. Now, we're almost done. But where do we substitute that in? Can I pick any equation on the whole page? I want to put it in exactly what Bosman just said. I want to put it in where it only has 2 variables. Because if I put it in one that has 3, I still aren't going to know 2 of them. So, I don't know. I think I'll put it right up here. So it'll say negative 9 times 0 minus 3y equals negative 3. This is 0. So I have negative 3y equals 3, which means y equals 1. Now where do I go, though? I got to go back to one of the original ones. I'm trying to find z, right? So I'm going to actually pick this middle one because it has a plain old z. So it'll be negative 6 times x, which is 0. And then it said, sorry, minus y, which is 1, plus z equals 0. Well, this is 0, so if I add 1 over there, I get z is also 1. So the ordered triplet I have is 0, 1, and 1. This one's really easy to check, guys. If I plug it back in, I get 4y minus 4 minus 6 is negative 2. If I plug it in here, I get negative 1 plus 1 is 0. I plug it in here, I get negative 2 minus 1 is negative 3. Okay, it's pretty easy to check that one. All right, so you kind of got the idea behind doing 3. They're not super fun, I get it. Yeah. All right, then we're going to do word problems. I got good news and bad news. The bad news is there's word problems. The good news is you don't have to solve them. On the quiz on Thursday, the first part of the quiz doesn't have word problems and you have to solve them. The second part of the quiz has word problems and you just have to set them up. The reason is, if you screw up the setup, are you going to be able to solve it? No, so I'm not going to double whammy you, okay? I just want to see that you... Now, what would an even nicer teacher tell you? You can solve them for extra credits on a quiz. Yes, you can solve them for extra credit. All right. What you do have to do for points is assign a variable and write the equations. Yes, they're both here. Tyseer, this is for you. It says you're leaving early. I'll print you the notes, okay? And Omar, there's a note here for you too. All right. This is what you have to do, guys. You have to tell me what x and y stand for and then write the two equations. That's what it's going to look like on the quiz. The senior class at High School A and High School B planned separate trips to the county fair. The senior class at High School A rented and filled 12 vans and 14 buses with 888 students. Does that sound like an equation? Mm-hmm. High School B rented and filled 2 vans and 6 buses with 324 students. Each van holds the same number of people, and each bus carries the same number of people. Find the number of students in each van and in each bus. When it says x equals and y equals, I want you to tell me what they represent. Do not write x equals van. Because it's not the numbers of the van, it's not the cost of the van, it's not the miles per gallon you get in the van, it's the what? Number of students that fit in a van. And what is y going to represent? Number of students that fit in the bus. If you go to the end of the question, you can get that part of the problem right without ever reading the question. Because the last sentence always tells you what you're looking for, right? Okay, you just got the easiest point of the quiz. Now you got to write the equations. I love this kind because there's 2 sentences that clearly give me 2 equations. 12 vans would be and would be plus. 14 buses would be 14y. We got 888 students in there. Who's got the other equation for me? Okay. Now, if this wasn't a quiz, and it's not, it's notes, could you all solve that? Somehow solve that system? Decide to multiply the bottom one through by a -6 and the x's would drop out, or you could do substitution or whatever you wanted. I'm going to go with it's notes. We practiced this a lot already. Let's move on. Does that sound okay? All right. This is a harder kind for most students to understand. Let me see if I can make this font a little bigger.
Are there any word problems with 3 variables?
We are going to do word problems with 3 variables eventually, because we'll solve them with matrices. We're not going to solve them by hand. All right, no, there's none on this quiz that have 3 variables. No word problems. All right. Everybody ready? A boat traveled 250 miles downstream and 250 miles back. Downstream and back is each 250 miles, okay? So there's a river and the current is going one way. When the current is helping you, that's called downstream. They went 2 miles down the stream. Then they came back another 252 miles, but the stream was working against them. Okay, example. They drove their boat 20 miles an hour. The stream was 5. When the stream water current was helping them, they made 25 miles an hour. When it was going against them, so if the water was going, or the boat was going 20 and the water was helping them at 5, they'd get 25. Does that make sense? If the boat was going 20 but the water, they had to push against the water, they'd only average 15 miles an hour. Does that make sense? Okay. So this is a rate time distance question where we don't know the speed of the boat or the speed of the current. So I'm going to stick with X's and Y's. X is going to be the speed of the boat, and Y is going to be the speed of the current or the water. I like to do these with a little chart. You certainly don't have to. Rate times time equals distance. Oh, that's a scrappy little chart. All right, so we have downstream and upstream. Downstream is, oh, missing a little. Okay, fill in something you can tell me, guys.
The distance is 252 miles down.
Each way. Okay, what else do you know?
The time is 12 hours down.
12 hours down, and it took 36 to get back. It's a long trip. Okay, we are going to eventually just divide, yes. But the rate here, downstream, what was happening with the X and the Y's? They were working together or against each other? Together. So we're going to put X plus Y. On the way back, what happened? Okay. So my equation says the rate of 12 was multiplied by the time of 12 was multiplied by the rate of X plus Y and became 252. I'm not going to distribute because I'm going to cheat and do a Basmaset and divide in a second. The other equation says 36 hours when X, the boat and the current were working against each other, got them the same distance of 252. Now, I didn't divide earlier, but this is just too good to resist, because if I divide both sides right here by 12, I get X plus Y equals, what's 252 divided by 12? Okay. On this one, if I divide both sides by 36, I get X minus Y equals 7. Now I have an Algebra 1 problem. Right? Add those together, I get 2x equals 28. X equals what? 14. If I put a 14 back in for X, Y has to be? So if this were the quiz and you wanted the extra credit, you would say the boat is traveling 21 miles per hour, and the current is what? X was 14, yes. It's 14 and 7, my bad. All right. This same setup works, guys, when they talk about a plane is flying with the wind or against the wind, okay? With the wind and against the wind. All right, there are 2 more word problems on your sheet, and I kind of want to skip both of them.
All right.
Because when you read this question, what does this remind you of?
Did you know that's on Netflix?
I did.
Bill's school selling tickets to a play. On the first day, the tickets sold 12 adult and 3 students for a total $120. School ticket $136 on the second day by selling 8 adult and 9 students. It's just like the buses and the vans, isn't it? If I wrote A is the dollars for adult ticket and S is the dollars for a student ticket, what would that first equation be? 12 adults plus 3 students is 120. The school took in 136 by selling what? Okay. 136? Thank you. All right. So you could solve that if you had to, or if you wanted for extra credit on the test, but it's very similar. Read the next question. I would, yeah. Like multiply the top by a -3 and then add it so that the S's dropped out. Do I need to do number 18? We got daylilies and shrubs and 2 clear sentences, right? All right. We'll set up some off worksheet 5 tomorrow because there's some different kinds on there. So tomorrow we're going to have about half the time talking about matrices and half the time to work. And then the next day the homework check is due. So look at worksheet 5, all those word problems tonight, so that you can ask me questions tomorrow. All right, we're moving on to ones that aren't linear. This is a line down here, yes? This is not a line. It's actually something probably like a hyperbola. If I draw a line through there, could I make that line intersect those once? That would be a little tricky, but could I draw a line that went like this and just barely hit once? Could I draw a line that hit both of them, so it had intersected twice? Could I draw a line this way that never intersected either one of them? Okay, so we might have 0, 1, or no solutions to this.
Yes.
Just thinking ahead. Okay, you don't know all about ellipses and hyperbolas yet. That's next semester. What we're going to do is solve by substitution. Rearrange this so that it says either x equals or y equals. What would it say? Okay, can I write it as 2 minus 3x just because that feels better to me? You can write negative 3x plus 2. Now we're going to plug this in for the y's, and it's going to be plugged in 2 places in the other equation. It's a hot mess. It's x squared minus 2 times 2 minus 3x, quantity squared, plus 7x, minus that same quantity, minus 7 equals 0. Do you see a little room for making a mistake here?
No,
Okay.
Hopper, I do everything right.
Okay. Lots of very careful algebra involved here. Too many of you continue to square this and tell me it's 4 plus 9x squared. There is a middle term. What happens when I FOIL that out? I get 4 minus a 6x and minus a 6x is minus 12x. Negative 3x times negative 3x is plus 9x squared. What do I have to do next? I need to distribute the negative 2. Can I distribute the negative back here, guys, at the same time and get rid of at least one of the set of parentheses? Okay, now do some distributing and then play. I get to add like terms together. There are too many terms. Okay. And they're not nice numbers. Negative 17x squared plus 34x minus 17 equals 0. Out of that mess came something that's really not too messy. Because why? I can divide everything by negative 17, and I end up with x squared minus 2x plus 1 equals 0. Which factors? X minus 1 and x minus 1. So I get x equals 1. One solution only, yes? X is 1. Okay, what do I have to do then? Yeah, but there's a really easy place to plug it back in, isn't there, right here? It says y is equal to 2 minus 3 of those x's. 2 minus 3 is negative 1. So I get the ordered pair 1, negative 1. These do intersect in one point only.
You know what really sucks? If we would have done all that and the answers.
It won't be on a test or quiz, I promise, okay? All right, number 20, what are we going to do here? This one, I think, has more than one solution. I want to talk about that. Can I just switch these guys around so it ends up with 2x minus 2 equals y? Plug all that in here and here. I'm going to go kind of quickly. Just go, it's fine. Oh, good news, we don't have something to distribute this time, right? Oh, on that one. We do have to distribute back here. Okay, what's 2x minus 2 times 2x minus 2? How many x's? Yep, minus 4x and minus 4x would be minus 8x. That's because there was one here and one from back here. Nope, you're good. Plus 4. Okay, this is the foiled together business right there, okay? Plus 3x. Then I got to distribute this guy. Plus 6 minus 42 equals 0. Okay, down to some algebra 1. At least the collecting of like terms is algebra 1, right? Oh, this was a 38 right here?
That would make a big difference.
Thanks for catching that now, not later. All right. So we just had an 8x squared, and then we had a minus 8x plus 38x minus 6x, which would be 24x. And we have a 4 plus a 6 minus a 42. Oh man, guess what again? Yeah, there's no x, but we can divide everything by 8. What if we had factored the 8 out? Would that matter later? Can 8 ever equal 0? No. All right, so we can just throw it away. X minus plus 4, x minus 1. Did I do that right?
Yep.
Okay, this time we have how many solutions? Okay, so we have a negative 4 for an x or a 1 for an x. If I put a negative 4 in here, I get negative 10 for y. If I put a 1 in there, I indeed get a 0. All right, can negative 4, 0 work? No, you can't like mix and match the x's and the y's. That's why it's important you write them as ordered pairs as you go, okay? Otherwise, you get an answer somebody's written down x equals -4, x equals 1, y equals -10, y equals 0, and they're not ordered pairs. It doesn't make any sense. Any questions on that part? Okay, you are now able to do worksheet 3, 4, and 5, and hopefully get yourself ready for the quiz. All right, I'm switching over to talking about matrices. This is worksheet 6. I really want to get to multiplication for the last 4 or 5 minutes, so we're going to go quickly through adding and subtracting. All right. Quick introduction to a matrix. A matrix is a way of organizing numbers. It's like a spreadsheet. This question says a furniture restorer refinishes chairs, tables, and dressers. He spends time removing the old finish, sanding, and then refinishing. So chairs, tables, dressers take time to remove, sand, and finish. He's got it organized in a little chart here. Does everybody understand what that's saying? That's a matrix, okay? When the matrices, we need to talk about the size of a matrix. That is called the dimensions. It is the number of rows which go across this way by the number of columns that go up and down this way, like the columns on the front of a house. You ever see a fancy, like the Parthenon? Is that the building that has a bunch of columns still standing? Okay. So those are columns when they go up and down. So this down here has 2 rows and 3 columns. It is called a 2 by 3 matrix. Those are the dimensions. This little note says, one way to remember that rows come first is to think of RC Cola, rows by columns. Do any of you even know what RC Cola is? Okay. Pepsi and Coke are the big sellers, right? But it used to be there was a pretty close third runner. Not anymore. Nobody's even heard of it now, but RC Cola, okay? RC still sells. You can still buy RC Cola. All right, guys. This, I'm going to pretend that this is the amount of money, just because I want you to see that there's a usefulness for this, in my checking account and in my savings account. I have $6 and a -2 for some reason. Okay? I go to the bank and I make a deposit into my checking and into my savings of $3 and $1. When I add those together, I now have what balance in my checking and what in my savings? You just added 2 matrices together. This is not mean 31. It means a 3 in row 1, column 1, and a 1 in row 1, column 2. You can add and subtract matrices only if they are of equal dimensions. Does that make sense? Okay? You can only add and subtract them if they're the same size. The second one here is a subtraction problem, so it's kind of painful. I'm going to write it out. You don't have to write it out if you don't want to, but you take this entry minus this entry, so you'd have -1 minus -6. These are the same size, yes? Okay. Then you'd have 2 minus -5. Then you'd have -4 minus 3. The next row would be -4 minus -2, -3 minus 6, and 1 minus 4. Anybody simplify those horrible double negatives? Okay. There was a lot of negatives there. We okay? Yes, you definitely could have changed this to plus and then changed all the signs on all of these, and it would have probably made it easier to do it in your head, yes? Okay? All right, moving on. These are disgusting, and I promise I will not give these with this many variables on a test or quiz, but this is a 1-row, 3-column matrix being subtracted by a 1-row, 3-column matrix. The reason that I give some that have a variable is because you can't do them in the calculator, and eventually, otherwise, if it was all numbers, you could do it in the calculator. So I want you to learn to do some with some algebra in them. This is a nice disgusting 4zx minus 2y. That's the new first column. Who can tell me the new second column? Yeah, be careful. You're subtracting minus a y plus 5, which would actually become a negative 3, a negative y, and a negative 5. And this mess minus this mess back here would be x minus 5z minus negative 1, or x minus 5z plus 1. Do you just want to cry? Yeah, those are just disgusting answers. Good news. What are we going to write for number 4? Yeah, undefined, can't do, not the same size. I'm good with any of that. Okay?
Nice try, Hawk.
Yeah. That's what Emma's going to write. Okay. This is called scalar multiplication. When you multiply everything by a single quantity. Let me give you an example. It's on the post-test or the final exam. There's an example where I give you the prices, $1, $2, $3, because I'm not very creative today. And I say, these are the things in my store, and I want to increase my price by 25%. I want to multiply everything by what? Be careful. 1.25 or 5/4 would work. Why am I going to do 1.25? Yes, if I multiply by 0.25, I'm only charging a fourth of what I was, right? I want to charge all of it plus another fourth. So I'd get 1.25, 2.50, and 3.75. Okay? So what are we going to get here? Negative 6, 9, negative 3, and positive 3. So you can multiply any size matrix by a scalar. You're just multiplying every entry by that number. That being said, I can do this, but can I then subtract this? Not possible. Yeah, nice try, Hoffbauer. Okay. Two quick questions that are just weird setups. This says this matrix came from multiplying some other matrix y by negative 3. How would we undo that? Okay, so divide all those by negative 3 and we get what? Okay. This matrix B was added to this 1 by 3 matrix to become this new 1 by 3 matrix. So what size was B? 1 by 3. 1 added what became 5? 0 added became negative 3. 6 was added to become, something was added to 6 to become 7. That seemed pretty easy? Okay, I have 5 minutes left to introduce you to matrix multiplication.
I'm gonna have to say no.
Okay,
He's gonna die.
matrix multiplication can only be done if, it says here, these must match. If you have a 1 by 4 matrix where this is rows by columns, it can be multiplied by a 4 by 4 matrix where this is rows by columns. The number of columns in the first matrix has to match the number of columns or the rows in the second matrix. Because you multiply each row by each column. Now, the resulting matrix, okay, will be the size of the leftovers. This one would be a 1 by 4. Okay? So, this matrix, let me explain it this way. Look up here for a second. If I'm making a chair All of these have to do with a chair, yes? It said removing the finish, sanding, and finishing. This is a 3 by 3 matrix where this number of rows were the type and this number of was the hours to use. Okay, the columns were the hours. This is what size over here? A 3 by 1, yes? Where this is the rows are the finishing products here, what we do, and this is the cost per hour. If I multiply this row by this column, half an hour of finishing times $7, plus 2.5 hours times $18 per hour for sanding, plus 1 hour times $10 per hour of finishing, I would get the cost for a chair. So hours by hours here would give me the type by the cost. I would get a matrix when I multiplied them together that would tell me the cost for a chair, the cost for a table, the cost for a dresser. What you do is you multiply each row by each column. I have nice color coding here. What size matrix is this? This is a 2 by 3. Guys, just pay attention to this example and then I'll let you go. This is what size? 3 by 2. Do they match up in the middle? The result will be what size? A 2 by 2. Here's my 2 by 2. You take each row, so I'm going to do row 1 times column 1. The resulting answer goes in row 1, column 1. What they did was they took 1 times 7, got it? 1 times 7, plus 2 times 9, plus 3 times 11. And they got 58. So I want you to help me do this row by the second column. What am I going to do? 1 times 8 plus 2 times 10 plus 3 times 12. That's 36, 46, 56, 64. It goes here. It goes in row 1, column 2, because that's what I multiplied. Here we go. Now I'm going to do row 2 times what? Column 1, which would be 4 times 7 plus 5 times 9 plus 6 times 11. It's 100 and something. 28 plus 45 plus 66. Anybody got me? 1. Okay. Don't get up yet, guys. Last row, second column will give me the answer in the second row, second column. 4 times 8 plus 5 times 10 plus 6 times 12 is 72, 50, and 32. 1. This is 139. And this is 154 maybe? Yeah. Okay. All right. So, tomorrow we're going to do this again, and we're going to do the ones on your paper. But I think this is a hard enough concept that seeing it over the course of 2 days will reinforce the idea. But it's row times column. Okay? Okay. See you tomorrow.